Have you ever really stopped to think about what keeps all that digital money, trillions of dollars in crypto, safe? Well, it's all protected by this digital fortress, built on super complex math. But what if? What if a totally new kind of key, one forged in the strange world of quantum physics, could one day just pick that lock? Okay, let's get into it.
All right, first things first, let's just try to wrap our heads around the scale we're talking about here. As of right now, an absolutely staggering 559 million people around the world own some kind of cryptocurrency. I mean, this isn't some niche hobby anymore. It's a full-blown global financial movement.
And the value? Whoa, it's just exploding. Projections are showing that the global crypto market is on a rocket ship headed towards nearly $8 trillion by 2030. That's a massive digital kingdom, all built on lines of code.
And the wealth being created here it's just astonishing. Get this, in a single year, the number of people who became Bitcoin millionaires jumped by 95%. This is way beyond just buying and selling. We're talking about the creation of immense digital fortunes, practically overnight. So, who exactly is riding this wave? Who's part of this global boom? Well, when you look at the demographics and the geography of it all, the picture might not be what you'd expect. And here's what's really fascinating. It's actually developing nations that are leading the charge. Turkey, for example, is way out in front, with over a quarter of its entire population owning crypto. You've got countries like Brazil, South Africa, Argentina. They're all adopting crypto faster than the global average, which is sitting around 10%. This is proof that this is not just a Western thing. So who are these owners? Well, for the most part, we're talking about young adults. In that 25 to 34 age group, more than 16% of men own crypto. And this is a really consistent pattern, across every single age group, men are almost twice as likely to own crypto as women.
And it's not just individuals anymore, not by a long shot. The big players are jumping in. We're talking major corporations like MicroStrategy and Tesla, and even the US government. They now hold billions and billions of dollars worth of Bitcoin. The stakes are getting higher, literally every single day.
So, with all this digital wealth being stacked up, everything, and I mean everything, hinges on one critical thing: security. And that security is now facing a potential threat unlike anything we have ever seen before.
Which brings us to the big question, right? How in the world do you protect a digital treasure chest that's worth trillions of dollars? The answer is buried in a field of mathematics that is the absolute bedrock of our entire digital world. And that bedrock is called cryptography. It's basically the science of making digital locks and keys. It's the magic that allows for secure transactions on a decentralized network like Bitcoin without needing a big central bank. And it's the very same tech that keeps your online banking safe.
But there's a problem, a big one. On the horizon, scientists are building incredibly powerful quantum computers. And theoretically, these machines could one day become a kind of master key, a skeleton key, capable of breaking the very cryptographic locks we all rely on today.
Just stop and think about the implications of that for a second. What happens if the lock that protects trillions of dollars, our entire digital financial system, could suddenly be picked? The whole thing would be completely vulnerable. But what if you could build a different kind of lock? A new one, an unbreakable one whose security isn't guaranteed by complex math, but by the fundamental, unchangeable laws of physics itself.
Well, scientists are working on exactly that. It's called quantum key distribution, or QKD. Now, the old school version of QKD basically forced you to trust that the hardware, the little machines sending the key, was absolutely perfect. But this new method, called device-independent QKD, well, it takes trust right out of the equation. Its security is guaranteed by the laws of physics, period.
And this is the actual machine they used. It looks incredibly complicated, I know, but the basic idea is kind of simple. On the left and right, you've got two different locations, and each one has a single atom. They're linked together by that optical fiber in the middle. The whole goal here was to use this crazy setup to create a totally secret key between those two atoms, proving this kind of ultra-secure communication is actually possible in the real world.
So here's how this unhackable handshake works. First, they link two atoms together in a special quantum state called entanglement. You can think of them like cosmic twins. What happens to one instantly affects the other. Then they use particles of light, photons, to generate a secret key. And here is the genius part. Because of quantum mechanics, if a hacker tries to spy on that light, the very act of looking at it messes up the system. That disturbance is detected instantly, which means the eavesdropper is caught red-handed, and the key becomes useless. It's basically a lock that screams when someone tries to pick it.
And get this, they didn't just pull this off on a lab bench. Nope. Researchers successfully kept this unhackable quantum link going over 100 kilometers of optical fiber. That's about the size of a major city.
And these graphs? This is the proof in the pudding. What you're looking at here is basically how fast they could generate a secure key over different distances. The really important part is that bottom graph. Even as they stretched the fiber out close to 100 kilometers, they could still generate a secure key. This is the hard evidence that this whole concept actually works over the kind of distances you'd need for a real-world network.
So let's just take a step back and remember what's really at stake here. We're talking about a mind-boggling amount of concentrated digital wealth. From the nearly 1 million bitcoins supposedly held by its mysterious creator, Satoshi Nakamoto, all the way to the massive holdings of companies and even governments.
And this right here is the heart of the story. On one hand, you've got this vast, growing digital treasure, billions upon billions of dollars, all secured by today's math. And on the other hand, you have this experiment, a working model for a next-generation vault, secured not by math, but by physics itself.
You know, this breakthrough isn't really just about protecting Bitcoin or other cryptocurrencies. It's much bigger than that. It's about securing our entire digital future, everything from global financial systems to top-secret government communications.
So what did they actually tangibly achieve? For the first time ever, they sent secure, finite-sized keys over a real-world distance, generating over 135 kilobits of completely unhackable data. This takes the tech from being just a cool lab curiosity to being a practical demonstration of what's truly possible.
And hey, it's not just me saying this is a big deal. The researchers themselves put it perfectly. They said this work closes the gap between proof of principle, experiments, and real-world applications. This is a major, major step forward. Which leaves us with this one final critical question. We are building our entire world on digital foundations. And to make sure those foundations don't just crumble one day, is it inevitable? Does our security have to evolve to the quantum level? It sure looks like the race is officially on.